Hey guys, good morning. This is Dr. Primus here, Dr. Veku. You can call me that if you want. So this is a live stream that I'm doing, and it is an introduction to AI. This particular session. So I have an 8 weeks course on AI, Advanced Artificial Intelligence. So it's going to be like a master's course. Well, it's designed for master students, but then we are going to share it with you. We are not going to make it as intense as a class is, right? But we're going to walk you through some of the concepts that you would treat or you see in an advanced artificial intelligence class. So this is basically what we're going to do. And you can, I'm going to share the link for us to watch this for those who are on different platforms. So let me see. Let me copy the link here. Just give me a moment. We're going to start soon. I'm sharing this across my page on Facebook, I think YouTube, LinkedIn, and some other pages. I was trying to go live on TikTok, but I don't have my TikTok keys. Unfortunately, because I don't have 1,000 subscribers on TikTok yet. That's why I'm not able to do that. So I'm going to just do it on this platform. And guys, feel free to to join me. Ask any questions you may have. We're going to walk through this process and we're going to make it really nice. So I'll share this on my status as well. And please share this live video so others can join. I'll give it a moment as people join. All right, I will share my screen in a moment, and we're going to, we're going to do a lot of things, right? And feel free to ask questions, to post your comments. Please feel free to post comments if you have them, and you can also be invited to join. You can, if you want to join our discussion, you can join us. Oh, I see Manuel Dirisa. Courage, grand frère, que Dieu soit avec toi. Merci bien, Dirisa. Merci bien, je t'en prie. Toi, ça va? J'espère que tu vas bien. Et le ministère, Crois-tu de Jésus-Christ? Ouais. Okay. All right, guys. Thank you so much for being there and watching. Dirisa, thanks for sending your comments there. So please share this video so we can, so I'll share on my Facebook page so we can follow. All right, let me get the link and share my WhatsApp status. Give me one moment, guys. All right, I will share again. Okay, so I've shared the page on LinkedIn. It's on YouTube as well. So guys, feel free to jump on and ask questions. But then we will be starting very soon. I'll share my screen very soon and just walk us through what this is going to look like. Oh, merci, Sembe. Merci, Sembe. Sembe is right the way from Garoa, I think. Dirisa, Emmanuel Dirisa is a priest of the Archdiocese of Garoa. I believe. Simbe, thank you for joining. He was my student actually, Emmanuel Dirisa. Emmanuel, I'm excited to have you watching. All right, I think we have about 7 people joining. Please let people come in, and we'll see. We'll be doing this every week, and it'll be from 10 o'clock a.m. my time, 10 o'clock here. I think 10, 11, 12, 1, 2, 3, 4. It's going to be 4 o'clock Cameroon time, 4 or 5 Cameroon time. And if you're in Nigeria, it'll be same time, 4 or 5. And if you're in Europe, for Europe, maybe UK and other places, it should be like 6, I believe, or if I'm not mistaken. So yeah, that's going to be the time we'll be doing this. And we're doing this weekly because the course is designed to be a weekly course, right? And it's 8 weeks, but it's going to go more than 8 weeks because we'll be diverting. We'll be going into different things, answering questions, talking about different things. We'll answer all your questions, any question you may have, right? We'll be answering them here. So yeah, feel free to invite others to join us, guys. Let me share this on my other platforms. All right, I see a couple of people watching us. Give me a moment, guys, to share this out. And then we'll make a schedule and we'll be sharing this. We'll be doing this every week. Okay, let me share it to another group. All right, guys. I think we have 5 people watching. So Aristide, we are listening. Thank you for joining, Aristide. Appreciate it. We have Prof. Kingsley. Prof. Please join this session. We are ready to have you join us. If anybody is willing to participate, you can join us. But then let me go ahead and present. Let me see. Share screen. Okay, I'm going to share my screen. So I want to be, let's see. I'm going to share my screen. All right. So I will share this particular tab. All right, guys, let me know if you can see my screen. So as I said, we are going to be discussing advanced artificial intelligence, right? And I said it's a master's level program. For those who are interested in artificial intelligence, this is going to be like a master's program in artificial intelligence. This is a course that is designed for master students at the university, but then I decided to share the summaries with all of us share the the structure. This is all about AI as it is in its current state, right? And all the tools, the chat GPTs and everything, all of them are built with these concepts. All of them are built using some of the algorithms that we'll be seeing here and expressing through this course. So it's designed to be an 8 weeks course, but it's going to take longer than 8 weeks. Why? Because each week has a lot of depth, right? Master students typically have a process to follow and they're all dedicated for it. And that's why you see that it's 8 weeks for them. But for us here who may be from different backgrounds, with different orientations, with different IT levels, it would take more than 8 weeks. So we'll be doing this every Saturday at 10 a.m. my time. That's about 4 or 5 Cameroon time. UK time should be 6 or 5 or 6. I don't know. You can convert it to your time, right? And yeah, that's how this is going to work. This is supposed to broadcast on TikTok as well, but my TikTok subscribers are still around 700. So head to TikTok and subscribe so we can get the 1,000 and be able to obtain our keys to do it on TikTok. Normally, I've been doing this on TikTok Live directly, but then I decided to stream it to other platforms. So this is streaming on YouTube. It is streaming on, I use the Primus Learning YouTube channel, actually. It's streaming on Facebook pages, and it's, streaming on LinkedIn as well, Primus Learning pages. But on TikTok, it is the IT tech guy, right? So that's my TikTok name. You can head there and give me a follow so that I can be able to stream this on TikTok. So in TikTok, my account is IT underscore tricks. IT tricks. That's my TikTok account. IT underscore tricks. All right. So yes, as I was saying, this is going to be not difficult. It's not. I don't intend to be coding here, but I may show you snippets from time to time. I don't intend to go so deep because I've made the concept simple. I will break down the concept so that progressively you can see how ChatGPT is what it is when you type and you get a response from ChatGPT. What it takes to get that response, right? When you do it on Gemini, or when you hear of models that I'm using, the Sonnet 4.5 model, what does that mean? When I'm using this and that, what does that mean, right? So we're going to walk through. And also, if you have any questions, please feel free to ask. We are here to answer any questions in IT, starting a career in IT or anything, right? Anything that you may really, show comments on stage. What does this mean? Chat only lets you display live comments directly on your stream. Please note that some platforms like Twitch. Okay. Yeah, I could do that. This allows me to share comments, but I'll have to reduce the width of this because it will block. I think I will just turn this off for now because it blocks most of the screen and we can see. All right, so let's see if we have more comments here. Let's see that. Okay. No comments. And please feel free to share any comments you may have and share this on your platform so we can have more people. So we have nine viewers. That's awesome. Thank you for joining, guys. All right. So as I'm saying, this is going to go on for 8 weeks typically, but you can walk through and see what it does. This first week is going to be an introduction, but you feel free to ask any question, whether it's in AI or in anything in IT, how to get started, really just learning about IT in general. Any questions you may have, if I don't know the answer immediately, I'll research and get back to you, right? I will be available to answer those questions. those that I can. I don't assume to have a lot of knowledge in IT because there are a lot of people who are very smart and who know a lot more than I do. So the little that I have, I can share, and those I don't know, I'll research. I'm very good when it comes to finding answers to questions. So that I can do for all of us. All right. So as you can see, the course is designed. The first week is just a basic introduction to to what AI is all about and all that, right? So that's where we're going to start. So when you come to this platform, you're going to do this, and it will just bring you to the introduction. And you can see the introductory page right here, right? Although it would do this because it displays a lot of information. I didn't want to be dealing with all the. I'm not here to do a nice web design, or I'm here about the content. So this is just a quick page that I put together for this, right? And so we're here to talk about artificial intelligence, what artificial intelligence is all about. So AI is artificial intelligence, the abbreviation, of course, is AI. And it's simply a simulation. They're calling it a simulation of human intelligence, or an imitation of our human intelligent processes. So what does that mean? That means that AI or AI systems, or any system that you're building with the intention of making it an AI system, is supposed to imitate the way the human being processes information, the way the human being gets information, goes through that information, reviews the environment, gets, and makes decision all out of that information. That is basically what AI is, right? And this is done by different systems, machines and agents. You hear different words. You hear things like AI agents. You hear things like AI systems, machines, and so on and so forth. Computing systems. This is mostly achieved through computing systems. And some of the processes that we're talking about include things like what the human being is able to learn. We are able as human beings to learn. When you are born empty with no knowledge, with nothing, like a blank page. And then over time, you fill out that page with a lot of information. As you grow, you really become very knowledgeable. You become a beacon of knowledge, right? You grow into knowledge. You go to school, you learn things. The human brain processes that information, and it's able to reason it out, and it's able to correct itself. Some of the false illusions that you had when you're growing up as a child are not the same things you have today. You've corrected yourself. AI, therefore, is imitating that human capability, and it's learning. And so you hear a lot about learning models. You hear a lot about machine learning. You hear a lot about AI's capability to learn. And so we have to train AI in order for it to learn and be able to reason and be able to correct itself after learning. And so you hear about training data sets. We'll be talking about training data sets. So you're training AI so that it can learn, right? It can learn from the data that you're giving it. You hear a lot about training data sets, right? And so on and so forth. And you hear that data is so important in AI that it cannot be overemphasized. This is going to be a big thing. And so AI is basically a field of computer science that is really just dedicated to creating systems that are capable of performing tasks that require really human intelligence. That's all that there is in AI. And the tasks, as I mentioned, they include things like reasoning, planning, learning, understanding, and solving problems. Really solving problems. That's basically what AI is. If you have any question about this definition, just ask. And AI has developed over time, right? Like it's gone over a historical transition. It's transitioned from different periods through the 1950s to the 1960s, right up to today. You hear about Alan Turing. You will be hearing about the Turing model very soon, I think week 2 or 3 in this course, uh, where in 1950, this guy called Alan Turing proposed some theories, and these theories, and even John McCarthy, in the same year, began or term the term artificial intelligence, and it was at a conference called the Dartmouth conference, right? And so artificial intelligence is not beginning today. It's not beginning today. It started a long time ago, and you have other developments like these. And then in the 2000s, there was the breakthrough in big data and deep learning. As I told you about data. When data comes in, data is just information, right? Like all the videos we are doing, that's data. All the live streams we're doing, that's data or data. Some people call it data, or anyone you choose. All the Facebook posts you are making, that is data. How do you think that data is stored? Imagine the number of people who are live on Facebook, on Twitter, on Instagram now as we speak. Imagine the number of people who are writing stuff, who are posting videos, who are texting on WhatsApp, who are calling, making calls. Where do you think that information is stored? All that information is going through in this modern world in a very rapid way, in its varieties, in complexities, in its type. So big data is basically that type of data that flows in all shapes and forms. You hear of videos, that's the types. You hear of videos, you hear of text, you hear of Parquet format data, you have CSV data, you have different forms of the videos, audios, and so on and so forth. So data in our current state flows in different ways. And with the advent of social media from the 2000s going up, that data, the nature of data has just blown, right? It's coming in all varieties. And the data that is mined in 1 hour today is data that could not be mined in a century, in the 18th century, right? The entire 18th century could not mine data that we do in an hour today. So where do you think all that data is stored? Where do you think all that data is processed? So from the 2000s to 2010, the breakthrough in big data, in the fact that we're able to process that data, we're able to manage that data that is coming. And also with a breakthrough, it's not mentioned here, but the breakthrough in cloud computing. When we're telling you to learn cloud computing, it's not for nothing. The breakthrough in cloud computing made the big data and data mining very possible. Why? Because organizations are able then to store their data. You hear now that data is the new gold. Organizations are able to store their data in computing systems and use computing power to process that data and make it useful information. Else it's just junk, right? It doesn't become information until it is processed. It is just raw information, raw data. It's not information until it has been massaged, it has been cleaned up, it has been mined and processed, right? And so the advent of cloud computing really, exacerbated the growth of big data, and as a result of that, there's a lot of data to train these machines with. You see where we're going, to train these AI systems with, to train these algorithms with, so that as you give it information, it can process that information and give you back output based on all the knowledge that it's gathered from all of from the data that is coming in. So the advent of big data and deep learning really marked a turning point in the life of AI, right? And then you hear of the 2020s, where everything is AI. You hear of large language models. Who has not heard about ChatGPT, about BARTs, and the revolution that NLPs? You'll be learning what NLPs are, right? And the revolution that all of these have brought to AI. So we'll be touching on all of these, and so you see that AI has evolved over time. It's grown, and we are at a stage where really AI is untouchable, right? Right. We had a really huge age in AI. And so, yeah, the core things that really make AI what it is, as intelligent as it is the fact that it's able to learn. It's able to learn from experiences and improve on its performance over time, right? It's able to reason logically and solve complex issues just as human beings. It's able to perceive information and interpret data and make meaning out of it. To interpret its environment, it's able to figure out the information you give it, the variables. You'll be learning about variables that you give it, right? The things that you give it in the input. It watches, and it's able to perceive all that, interpret it, and make meaning out of it. And also then we're saying it's able to make decisions based on the data that has been given it, based on the information that you've provided AI. It's able to to make decisions. So let me see if there are any questions here. Wunge Senior, yes, exactly. Technological advancement. That's AI has grown as a result of the huge technological advancements that we've had. Thanks for your comment, Wung Senior. Appreciate it. And so yeah, that's where AI is right now. It's able to do all of this and also communicate, right? And there are key components that really influence AI systems. So we've already spoken about the data aspect. We've already spoken about the computing power, but then we haven't spoken about algorithms, the development of mathematical procedures that process data and enable learning and decision making. There are a lot of algorithms that have been developed over time, even in the time of great philosophers like the Pythagoras. You have Pythagoras theorem. You see how it's related, and all that those algorithms that have been developed over time, over the history. If you trace back history, it started with ancient philosophers who started philosophizing. So that's why you see philosophy is very important in any science that you do today. The philosophers, the ancient philosophers, the Pythagoras and the rest, right? They were they are the foundations of knowledge, right? They are the ones who developed most of the algorithms, those ancient algorithms. But over time, there's been a lot of development in mathematical algorithms and procedures. And mathematical algorithms are simply simplifications of the way we observe environment and the way we observe objects and all of that. And then there's as Wung Senior mentioned, there's technological development. Of course, there's a lot of expertise now in AI, and so it's driven that growth in the space, right? And there are different types of AI now, right? There are different types of AI, and it could be divided into different perspectives. You could divide it into capabilities and functionalities. These are different categories that define how intelligent and adaptable an AI system can be, right? And really, based on capabilities, you could say that there is narrow AI or what is called weak AI, which is simply a system that is trained and defined to be performing specific tasks, right? And so there's weak AI. So examples here would include things like Siri, Alexa. When you ask Alexa to do something, it will do that exact thing that you're asking it to do, right? If you ask a face recognition software to go and buy something, it's not able to do that. If you ask Alexa to go buy something, it's not able to do. It's only able to recognize what you're giving it, right? And so there is that aspect of capability when it comes to the types of AI. We are saying that weak AI is the one that is able to perform particular tasks, but is not able to do every other thing. And then there's what is called general AI, which is also known as strong AI, right? And this is when it comes to the general cognitive abilities of AI systems. So that's the type of AI that we say is almost reasoning like a human being. And so what are the capabilities in strong AI? The capabilities here will include things like reasoning, learning, and applying knowledge to solve problems, to solve complex issues in life. And this really requires a lot of details, a lot of information. And then, there's what is called artificial super intelligence. This is another type of AI, but it is still hypothetical because it is that type of AI that surpasses human intelligence in all its cognitive forms. And so we're saying that, and this is the type of AI where we're thinking in the next 10, 20 years, AI would be, where AI systems are able to do even more than the human being. They transcend um, human abilities when it comes to what? Solving and improving on issues. They are solving problems and they can self-improve. Imagine that AI can code, but then it can improve on the code that maybe you've asked it to build and continue to solve any other problem without your intervention. And that type of AI we're thinking will have goals and motivations. If you set as a goal for it to achieve this and it's here today, it will continue to work on it until it reaches that goal. And this is the type of AI where people are beginning to have a lot of fear. They are thinking, hey, it will take away our jobs. It will be a threat to human existence. It will go out of control. And so you hear theories like, those who decide to go by the via negativa. The via negativa is the negative way through which people are thinking, hey, this AI would terminate the human race. It would one day just decide to kill everyone. Robots will just decide to kill everyone. But that's really not where we are right now. Right. And so there's this is still theoretical, and people are believing that over time it will AI will evolve, but we are not yet there. Right. And so let me see if there are any comments here. No comments. I see we have 13 full viewers. Thank you guys for joining. If you have any questions, please feel free to ask. We're here to just talk. Right? Nothing too big. Let's just discuss. If you have any questions, please feel free to ask, and we are ready to answer. All right. So that's where we believe that AI would be in the next few years. And so you have applications of AI, and AI is now used in different industries, in different areas of life. You have healthcare, where you have AI being used for diagnosis, for drug discovery, for medical imaging, and so on and so forth. In transportation, where I worked in the transportation industry for some time, it was intriguing, to see how AI systems can track where fleets or truck fleets and all that are, track the locations where supply chain is happening, and optimize on it. I worked on model optimization for fleets and discovery of where to locate stores in the transportation and supply chain industry, right? Where optimizing on models that determine, through predictive analysis, determine where population is growing and where future stores can be located. And so you could have a feature in your model like future stores, and then you begin to optimize on that model to make predictions on where you believe in the next 5 years stores could be located. And from that, the predictions, decision makers in the organization could make decisions on where to build new stores, on where to open new stores. And that information is coming from data that has been given it over time and continuous work on the models that are involved in predicting predicting the location of future stores. And there is AI in finance when it comes to fraud detection. You can now do verification of people and systems automatically. And after 5 minutes, you're verified and qualified for whatever you're signing up for. And there's algorithmic trading where AI is able to do trade in the stock market, in the crypto market, and so on and so forth. And then there's credit scoring, where automatically this credit scoring may not be very visible to other people, but in advanced countries, credit scoring is a huge deal, where they want to see where you are with your credit and determine if you really qualify to take loans. And they do that by seeing the payment history that you have, right? Have you been paying your debts? Are you able to get $500 and pay back that person in 1 year, right? You're able to pay in installments. Are you able to do that without missing? And so they're able to track you down and get all that information and score you over a score of 1,000 or 800 or whatever, depending on the country, right? Risk assessment. It's available in the education industry, with intelligent tutoring, automated grading, learning analytics, and so many other things, as well as entertainment industry, gaming, and so on, music. There's some music that has been released, I think, and it's been making headways as one of the best, and it's appearing in billboards and in things, and it's AI generated, and it's beating all the artists out there. So AI really is in all these places. It's being applied in all these areas, and so it's a huge deal, guys. All right, that's where I want to leave this with the introduction. So we're going to look at how AI actually makes its decisions, how intelligent it becomes, how it's even able to, be doing whatever it's doing, right? It's a very important thing, and we're going to figure out how AI even comes about, and we'll be learning about intelligent agents, AI and its intelligent agents. So when we talk about intelligent agents, we are simply referring to agents that are able to intelligently make decisions. They're able to make decisions following certain parameters, following certain things that you've given it, certain guidelines that you're giving it, right? So this part where we are is called intelligent agents. And what are intelligent agents? They're basically those types of agents, that make decisions. They are AI agents. Remember, I told you, hear the word agent, and we'll be replacing it with AI, like AI systems. Could say intelligent systems or intelligent agents. So these are AI systems that are able to make intelligible decisions, that are able to make decisions that are thoughtful, right? Thoughtful. All right, let's see. AI is the way forward, and I will recommend everyone to get into it. Absolutely, Mr. Wong Senior. AI is really the way forward, and it's an area to look into, guys. It's an area to look into. All right. So when we talk of intelligent agents, we're referring to systems or agents or AI systems that are able to reason through a process and arrive at a goal, at a decision. And there are different types of intelligent agents, and there are different types of models of algorithms that are able to be applied into these intelligent systems. And these algorithms learn from interactions with the environment. We call this type of algorithms reinforcement learning. It is a type of learning. So AI systems are able to learn. Remember, we said they follow human capabilities. It's an imitation. That AI is a simulation of human capabilities, human thought processes, right, and decision-making processes. And so, through what we call reinforcement learning, you'll be hearing about these terms as we go. We'll break them down as we go. Through the term reinforcement learning, and we're saying that these are the types of algorithms that learn. Algorithms are simply, um, like mathematical mathematical processes that have been defined that do go through a particular thing, right? And these are algorithms that learn through interaction with the surroundings, with the environment. And reinforcement learning falls in the context of machine learning. You see that machine learning is a little bit different from AI. And we're saying reinforcement learning is a type of machine learning where an agent um, learns to make decisions by taking actions in an environment. And it does this to maximize what is called rewards. And rewards are like, hey, when you reach a goal, yes, yay, I've reached my goal. You've had a reward, and that reward is probably successful. You were successful in your mission. So if your mission is to leave from point A to point B, when you reach point B, you've reached your goal. And so you're successful in your mission, and you have a reward for doing that. And so we're saying reinforcement learning is therefore a type of machine learning. You see that there is a difference between um, machine learning and artificial intelligence, right? Machine learning and AI. There's a difference between those two. And we see that AI is more like the broad concept of creating machines that mimic human beings. While machine learning is like a small subset of that AI. And this allows allows systems to be able to learn from data and improve over time without being explicitly told to do so. That's machine learning. So machine learning is like a topic or it's like a section under AI. And so we're saying that reinforcement learning is a type of machine learning, and agents are able to make decisions by taking certain actions, right? So that is what is reinforcement learning is all about. And so intelligent agents are basically using these types of machine learning, reinforcement learning, to do whatever they're doing. And there are key components to this, right? To reinforcement learning. There's what is called an agent, and we've said the agent is a learner or a decision maker that interacts with the environment. So it's the AI system that interacts with its environment. And the environment is the world in which the agent exists. It's where the agent is. So if you provided data, it will learn from that data. If you provided objects, it would deal with those objects. And then the state is a specific configuration or situation the agent finds itself in. So it is, at what state is your agent? It is at this stage. It is at the initial state. You could say the initial state, it's taking an action. It's at the end, or the goal state. It's reached its goal, and it's at that stage. It wants to go back to its initial state. So you discover that in AI, it's always a process. The beginning, it goes process, output, and then the output could become input again. Beginning, action, output, just like that, continuous system. And then we have action, a move the agent can make to transition from one state to another. So an action is just the same like an action. You doing something. A move that an AI agent can make to move from one state to the next state. And then the reward, as we already said, it's feedback from the environment indicating the success of an action. So if you're able to move from point A to B and B is your goal, that's your reward. You have a successful mission. You've accomplished your mission. And then we'll be hearing about policy, which is the strategy that agents use to determine its actions. How does it determine whether it wants to, for instance, you have a bot in your house. How does it determine to go and clean on this spot where there is dirt versus going to clean on a spot where there is no dirt, right? The strategy, that strategy that it uses to do that is called a policy, right? So we'll be seeing all of this. And there are different types of reinforcement learning. And you hear about Q learning, and you'll be seeing this Q learning and what it does. There's policy gradient methods. You hear about this learning. There's deep Q networks, what is usually abbreviated DQN. And then there's actor critic method. There are other reinforcement learning algorithms out there. You know, how does the reinforcement learning process work? It starts with an observation where the agent receives a state from the environment. The agent receives a state from the environment. Remember, we defined environment up there as the surroundings where the agent operates. So the process begins with the agent observing its environment, and then it receives a state. So if your initial state is point A, that's where the agent receives the state. So its state is probably initializing or the initial state. It could be called initial state or whatever. And then there is decision making, where based on that state, the agent is able to select an action according to its policy. Remember, we said the policy is the strategy that that agent uses to be able to take actions. And then an action execution would be the agent performing the selected action in the environment. So if there are 4 actions for the agent to take, go up, go down, go left, go right. An action execution, therefore, would be the agent performing that action, either going right, going left, going up, or going down. You will see this very soon when I'm demoing in a practical graph board. And then you have the state transition, where the environment simply transitions to a new state from one state. And then the agent can update itself with the learning through the policy that it's made. So if you've received a reward, a successful reward, you have then learned that to move from point A to point B, this is how I do that move, right? So it's able to move that way. It's able to learn. Remember, we said AI systems are able to learn. So intelligent agents are able to learn, and then they update themselves. Self-correction. They update themselves based on the feedback that they received from the reward. And we're saying that one of the fundamental challenges in reinforcement learning is balancing exploration versus exploitation. We'll go into this in detail when I think week 3 or so. Exploitation versus exploration. So these are some basic concepts, and to demonstrate this to you, right? To demonstrate this to you, you would have to go to the interactive demo section. So all of these things that are discussed here, they have interactive demo section, and they have the code implementation and the different models, and you can see them right here and play with them, right? So we'll be walking you through these different things. And you see, I used some types of models here: deep Q network, just as we said, Q learning, and then grid world. All right, let's do the interactive one. And so what you do with this simulation is that you select an agent type. You remember we said there are different types of algorithms that are used. And so we've used those types of algorithms, and we've put that code using those algorithms. The code is built using those algorithms. And I'll be showing you how, right? And so if you choose Q learning will behave differently from random agents. Random agents will behave differently from SARSA or SARSA. SARSA will behave differently from DQN, and different models. And so you hear of different models. So when you hear that an organization built its thing based on this type of model, that is what we are talking about. It is basically some algorithms, that they use to build their systems. And so for this simulation, it's just a grid that we've done, like a graph or something, right? It's like a graph. Let me get the door. Somebody is at the door. Give me like 1 second, guys. Give me like 1 second. I'll be right back. Yeah, I'm back. So I wanted to get a door. Sorry. All right. So guys, this is how the agent looks. You select an agent, right? And these agents will behave differently in this simulation. And then you click on start. So look at the initial state. This is the initial state of this agent. This is the agent right here, this thing that is blinking. We are defining it as the agent. And you see the cell where it is. It's in cell 3-2. That's where the agent is. That's its initial state. So it has to learn its environment. Its environment includes all these other cells. It includes this cell. You see this cell is like dirt. I'm making this to be like a cleaner, like a board that is cleaning your house. Assume that this thing right here is your board. It's your house. It's like your floor. Assume that this thing is your floor in your house. And this right here is your board and it's cleaning. And assume that this is dirt in your house and these are clean cells. This is clean part of your house. This is the dirty part with the X one is the dirty part. And so if you're going to choose an algorithm, if you're building a bot that cleans the house and you're going to choose an algorithm, there are different types of algorithms. You want to figure out which one is best, which one best suits the system, so that you build a system that maximizes on its rewards, right? So what will happen here then is we've chosen this and we've set the stage. We've defined an initial state where the intelligent agent is going to make a decision, and it's making the decision through what we just defined, right? As it's going to either move up, move down, or move right. So you see, all this agent can do are 4 actions. We've defined 4 actions. And in the code, you see that we've defined 4 actions. And the actions are up, right, left, down. And you see that this algorithm this agent is only able to perform 4 actions: up, left, right, down, to be able to achieve its goal, right? And so this is what the process that it will take. It will observe its current state, and we define its current state as S. And then it will select an action, which we defined as A in our code. It will be using what is called the epsilon greedy policy. And then it takes an action. The action again is A, and observes its reward. It observes if that action is successful or not. And then it goes to a new state, which is S. And this is the algorithm that is used. This is the algorithm right here. And then it transitions to a new state. So to do this, you just have to click on start right here. You see, we've started. You see your algorithm is moving up, down, left, and it's cleaning. Observe what happens down here. It's being measured. The accuracy of this model is being measured by the steps it's taking to clean this thing. By the time it reaches its goal, you see that this algorithm is either performing higher than the other one or not, right? And so this in AI is called accuracy. How you hear about models being accurate. How accurate is your AI model, right? And so it's learning from its environment and it's making decisions whether to go right or left. And it's going left or right and cleaning, you see? And so the random, the learning agent has reached its goal, it's completed its task, and it went through 97 steps to be able to achieve success. And success is 100, right? And so that is basically what it did. And you see these colors, you see the colors. This is the obstacle, this is the agent, this is the visited cell, this is the goal. The goal is green, it's claimed. And then the path it takes is marked as that, though the path part is not working as expected. So this is how this algorithm behaves. Then if you reset this, right? If we reset this and take the next algorithm, if we take, for example, the random algorithm, this one is expected to clean randomly, to just be moving up and down anyhow, right? Without a specific, a specific structure. You see how it works. It perceives the current state, ignores the history and learning. So this one just does it. It doesn't take into consideration the training data set that it's been given. It doesn't take into consideration the historical context where it finds itself, the history, the learning that it learns. It just selects a random valid action and takes. What are the valid actions? The valid actions are four. Somebody can list them: up, down, right, left. And you discover that this type of agent can even be performant more than the Q-learning agent. And so in different scenarios, you could decide to take different types of agents depending on your work. So you see, we'll have to reset this. So if we do start, right, it resets. When you say reset, you have to do start, and then it starts cleaning. So this one is just randomly moving. Let's see how many cells it takes to achieve its goal. So this is the random algorithm. It's just going. Let's see if anybody has questions. Sobrel, thank you. I appreciate it. So this algorithm is going through and cleaning. You see, it's just randomly moving up and down and going, but it has to finish the job. It has to complete its job. Thank you, Cecile, for joining. Appreciate it. All right. So it has to finish its job. So it's going around and cleaning. It has just one cell left. It looks like it made it. The other one was more performance than this one, you see. So it's gone even more than 100 and it's still not reached its goal. So it's still going around because it's random. You see, sometimes if you just take random algorithms, they will not work as expected, like this one is doing. So it will take probably a long time to achieve this goal. Like the human being, if you're just wandering around, like if you're that type of human being who doesn't make decisions, who doesn't structure things, you see your reasoning, the way you achieve a goal could be random and it's not efficient, right? You see this guy is just beside it, but it's not doing it. Finally, it gets it, right? And so it's reached the goal, it's complete, and it took 196 steps to complete its action, which is, in terms of accuracy, it is not accurate. It's horrible in terms of accuracy. All right, you could try another type of agent called the SASA agent, and this is how the SASA agent behaves. And this is its algorithm. And so if you hit update here and run, you see this algorithm will then move around. I think we'll have to hit start again. It will move around and do its work, right? So you can play around with this. This website is available. It's called mscs633.com. That's the course I'm teaching in a university, and I just put it here so you can use it to play around with it. And really, this is basically advanced AI. This is what universities teach their students at the advanced master's level. All right, you see this one is going around and doing its work, it's going around and cleaning, and you make decisions based on that. All right, so that's where I want us to end today. Guys, if you have any questions, so next week we'll start with week 2 and we'll look at decision making, how algorithms are able to make decisions. And we'll see search algorithms as adversarial search, making simple decisions, utility theories. Week 3 would see different types of models, NLPs, so natural language processing. You hear about natural language processing models, n-gram models, named entity models, text classification, and so on. I didn't look at the code implementation today because this is simple, right? The code implementation is simple. Here, you're simply importing the various packages or libraries that you would use to do your work. Next week, we'll talk about what these libraries are. It's just code that has been built, functions that have been built to do specific things, and all of that has been packaged together and put out there as available online as free code, what is known as open source. And so you and I are able to use it to do different things. If you are doing mathematical calculations, you can use what is called NumPy because it's been built with mathematical calculations in it. It can sum, it can do every type of thing. And if you'll be doing plots, you can use what is called the Matplotlib. And so it's been built and you can import it. How you use it is you import it into your tool, into your code, into your environment, wherever you're working, right? And you use it. You import others like Gym and so on and so forth. And then here you're just defining your function. So we're defining a function and that function will be doing specific things. So the grid is this is just that box that we saw there. And what will it be doing? It's defining what the agents will do. The agent starts at the position called position 00, right? You see, it starts at this position. And then the goal is at position 4. That's where, when you hear about the goal, it means it's reached cell it's reached that point. And then there are obstacles at positions this. You see where the obstacles have been placed. These cells, the obstacles are placed in these cells. And then the agent can move up, down, left, or right. Those are the actions that the agent can take. The agent can receive a reward of -1 for each step it takes, -10 for hitting an obstacle, and +100 for reaching the goal. So you see the reward type. You see the reward type that the agent gets. So when you get a +100, it means, hey, I reached my goal. If you move one step ahead, you have a reward of -1. If you go and hit an obstacle, sorry, you did not do well. You've hit an obstacle, and so you have a reward of -10, and so on and so forth. So the rest is just a function defining all of these things as we've set up there. The code, this is the code part of it, is just doing all of that. And so you see how we are setting our grid world environment. And this is the environment we talked about. The environment is like you're setting the variables, you're setting up your environment so that the agent can learn from that environment. Right, and so on and so forth. So we'll look at the code part next week. I wanted to end here today so that this video is not too long because it's an hour. We'll be doing 1 hour each session. All right, guys. Any questions? All right, I see a lot of comments coming in. No question for now. Thanks, Sabrel. Could you please share the link on the comment section? Yes, I will share this link on the comment section. So if you just go to mscs633.com, you will find it. So I added that to the comment section. Okay, so let's see. Great job, Doc. Thank you, Sister S. Appreciate it. Thanks for watching. All right. Oh, so I posted it on all the pages. Has it? Okay. Thanks, guys, for watching. Please feel free to ask questions, not only in AI, but in any other thing, right? Or anything, any challenge you have in AI or starting up in AI, feel free to ask your questions, and we should be able to have Thank you. And if you want to get started, you can go to primuslearning.io, to contact us, or you just hit our DM and we should be able to help you. Thank you, and bye bye for now.